This is the fourth part of the four-part lecture on engineering terms. This one is on energy. When we see how energy is defined and measured, we'll have a good grasp on the terms used in everyday science and engineering. As always, click on the spacebar to continue. We said in our lecture on mass that applying a force and moving an object some distance is a measure of the work we've done to that object. But here's our question. Where did we get the ability to generate the force? This question leads to our last concept called energy. Energy is another property of the universe that came at the Big Bang just as space, time, and mass did. Energy was also the last property discovered because it's hard to actually nail down what energy is. For our definition, energy is the ability to do work. And if work means moving something, then we can say energy is the ability to move things. But one thing people discovered as they were investigating energy is that it has two forms, potential and kinetic. Potential energy is energy that is stored or not yet used. There are many ways energy can be stored, like compressing a spring or putting an object on some height. Potential energy is energy that is available to be used. Kinetic energy is energy that is released and is now moving something. The object with kinetic energy is moving and also provides a force that can be applied to another object and make it move. Let's illustrate this. Let's say we have a 1 kilogram ball 10 meters high. The acceleration of gravity is actually 9.8 meters per second squared, but I'm going to round it to 10 meters per second squared because I want to use round numbers. The formula for potential energy is mass times gravity times height. So when the ball is on the shelf, it has 100 joules of potential energy. If we drop the ball, h approaches zero, so potential energy also approaches zero. But kinetic energy increases as the velocity increases. Finally, at impact, the potential energy is now zero and the kinetic energy is now 100 joules. And the ball hits the floor with a force of 10 newtons. Now, can you see that if I wanted to lift the ball back up to the shelf, I would also have to do 100 joules of work? What are the units for potential energy and kinetic energy and work? Well, let's examine the formulas for each one. The formula for potential energy, you may remember, is mass times gravity times height. Kinetic energy is one half mass times velocity squared, and as we've seen, work is force times distance. Well, if we break the potential energy formula down, mass, the units are kilograms. Gravity is an acceleration, so its units would be meter per second squared, and height is a distance, so its units would be meters. Kinetic energy, mass, again, kilograms. Velocity is meter per second, but velocity squared would be meter per second squared. And of course, we break down work, force into kilogram meter per second times a meter. But now if we look at each one of them, we can see that each one, the other two, potential energy and kinetic energy, can also be transferred to kilogram meter per second squared times a meter. Kilogram meter per second squared is a force, and so then that translates down to Newton times a meter. And then finally we can see all of them, potential energy, kinetic energy, and work, all have the same unit, the joule. The last concept talks about the rate of work. How fast can you move an object from one place to another? Since we're talking about work, the units will have to be joules, but we're also talking about a rate of work. So we have to divide joules by time to measure how fast work is being done. This rate of doing work is called power, and the units are joules per second. But power is also such an important concept, we give the unit its own name called the watt. Let's illustrate the concept of power by using these two balls. Both balls require 10 newtons of force to move them 10 meters, but the lower ball gets there in half the time, so more power was expended on the lower ball. Let's put these concepts together in a paragraph and create what we call the big picture of engineering. Okay, in order to do work, we draw from a source of potential energy, convert it to kinetic energy to create a force sufficient to overcome an object's friction and momentum and move it some distance. The rate at which we do work is called power. Okay, so now you should have a good understanding of engineering terms. You should know from where they're derived, what their units are, what they mean, and how they relate to each other. So congratulations. Good job.